Let's restart the lecture. So everyone can see the slide. Everyone can see the slide.
Yes, sir.
Okay. So we were at this point. We were discussing flexural shear cracking and web shear cracking. So flexural shear cracks occurs after the flexural cracking has taken place, and the flexural cracks we know that they extend more or less vertically into the beam from the tension phase. So when a critical combination when the flexural cracks will appear, when the what you say tensile stresses becomes greater than the modulus of rupture, the flexural cracks will appear and they will be more or less vertical. uh, they will propagate vertical into the beam from the tension phase towards the, you can say, compression phase. So when a critical combination of flexural and shear stresses are developed at the head of the flexural crack, that crack propagates at in an inclined direction, which is often flat. So what we were discussing last time, that this crack, web shear crack, this crack is almost inclined at an angle of 45 degrees. This web shear crack is inclined at an angle of almost 45 degrees, whereas this flexural shear crack, it is much more flatter as compared to this web shear. So this angle, this crack, flexural shear crack, will not be inclined at an angle of 45 degrees. So flexural shear crack, which was initially you can say flexure, then it meets the shear crack and it propagates in more or less horizontal or flatter, you can say, direction. Web shear crack, on the other hand, it propagates at an angle of 45 degrees. So if a web reinforcement, if a web, because we have seen that the shear stresses, they are maximum in the web part. Shear stresses, they are maximum in the web part because the width of the I section is very small, so the shear stresses are very high. So we need to uh, provide the shear reinforcement in the web. So if web reinforcement is not provided, such a crack may produce shear compression failure. ठीक है जी, shear compression failure. So if a web reinforcement is not provided, such a crack may produce shear compression failure. Shear compression failure क्या होगा कि in which the compression area of the concrete near the top of the bottom reduced by the diagonal crack. So basically what happens, as the vertical flexural crack propagates upwards, the neutral axis also move upwards. The neutral axis will also move upwards. So what will happen, that the compression region at the top of the, what you say, I section or the top of the beam, that will be reduced. So when area will be reduced, the force is the same. The force is the same. So larger force divided over the smaller area, it can produce a compression failure. So if a web reinforcement is not provided, such a crack may produce shear compression failure, in which the compression area of the concrete near the top of the beam reduced by the diagonal crack is inadequate to resist the forces resulting from the flexure. So what will happen, as the flexure cracks will propagate, what will happen, the neutral axis will move upward. So when the neutral axis move upward, you know that the upper part is subjected to compression, lower part is subjected to the tension. So that compression part area is reduced. When the area is reduced, the force is the same. So force divided over smaller area will increase the compression stresses. ठीक है जी. So which may result in a compression failure. So if a web reinforcement is not provided, such a crack may produce shear compression failure, in which the compression area of the concrete near the top of the beam reduced by the diagonal crack, which is inadequate to resist the forces resulting from the flexion. Is this point clear? This point is that as the flexure crack will propagate, the neutral axis will move upwards. As the neutral axis will move upwards, the compression region, which is at the top, that will reduce. The compression force remains the same, large. So when the larger force divided over the smaller area, the stress, compressive stress, will become large, and there is a possibility of compression failure. ठीक है जी. So if web reinforcement is not provided, such a crack may produce shear compression failure, in which the compression area of the concrete near the top of the beam is reduced by the diagonal crack, which is inadequate to resist the forces resulting from the flexion. So everyone agrees to this point? Okay. Can you hear me? Okay.
Yes, sir.
Okay. Let's proceed. Then, although the flexural shear cracks, so there are two types of crack, flexural shear crack and web shear crack. ठीक है जी. This is flexural shear crack and this is web shear crack. Although flexural shear cracking is the more common type, ठीक है जी, although the flexural shear cracking is the more common type, web shear cracking may occur particularly near the supports of the heavily prestressed beams. So web shear cracking, when will it occur? Near the supports, because near the supports, due to the pre-stressing, there will be high compressive stresses, and due to the applied loading, the bending moment at the, at the simply supported, in case of simply supported beam, the bending moment at the supports is very less. So tensile stresses are very less. So web shear cracking may occur particularly near the supports of the heavily pre-stressed beams, because the shear stresses are very high, because the web thickness of the web is very small, and secondly, there is only compression. There is no tensile stresses to cater or counter that compression. Web shear cracking initiates in the web without previous, flexure cracking, when the principal tension in the concrete becomes equal to the tensile strength of the material. So of course, when the stresses become greater than the strength, the cracking will initiate. ठीक है जी. So flexural shear cracking, which is basically, you can say, a combination of the flexure and the shear crack, which is more flatter, is the more common type of cracking. But the web shear cracking, which is more towards the, you can say, supports, near the face of the supports, and it's inclined at an angle of 45 degrees, is, you can say, less common. But in case of over pre-stressed beams, which are heavily pre-stressed, because we have large compression at the, you can say, throughout the section. So at the supports you have large compression, and the tensile stresses due to the bending moment are small, so that can initiate your web shear cracking. So web shear cracking initiates in the web when the principal tension in the concrete becomes equal to the tensile strength of the material. And web shear cracks, they are almost 45 degrees to the longitudinal axis, whereas the flexure shear cracks are more flatter, or you can say more horizontal or parallel to the longitudinal direction. So over shear design will be based on flexure shear cracking and web shear cracking. So over shear design is to ensure that flexure shear cracking and web shear cracking does not occur in over pre-stressed beam. ठीक है जी? Then, this type of web distress leads to the sudden formation of a large inclined crack. As earlier we said that the shear cracks, they are more shear cracking, it is more abrupt in nature and difficult to predict. ठीक है जी? So this type of the web distress leads to the sudden formation of a large inclined crack, and if the web reinforcement is not present, it will lead to the failure of the beam in one of the following ways. So, what are the possible failure ways? One, separation of the tension flange from the web. So you know that the lower part of the flange, ठीक है जी, that will be your tension flange, upper part is the compression flange. So separation of the tension flange from the web as inclined cracks extend horizontally towards the spores. Horizontally means these are your flexure shear cracks, which are almost you can say horizontal, less inclined, or you can say more flatter. So separation of the tension flange from the web as inclined cracks extend horizontally towards the supports. Then the second possibility is the crushing of the web. Crushing of the web results from high compression. Why high compression? Because as your crack proceeds upwards, the neutral axis moves up, the compression zone is reduced, the compression force remains the same. So the stress that is force per unit area, it will increase. So crushing of the web resulting from high compression acting parallel to the diagonal cracks as the beam is transferred into an equivalent tied arch action. This tied arch action is basically being used, this concept is being used in the what you say design, shear design of RC beams, and the same concept very much similar is used in the shear design of pre-stressed concrete beams. So the second possibility is the crushing of the web resulting from the high compression, which acts parallel to the diagonal cracks as the beam is transformed into the equivalent of a tied arch, is transferred into the equivalent of a tied arch. The third possibility is inclined tension crack near the supports. Inclined tension crack near the supports, which separates the compression flange from the web. So you know that at the transition points where the web and the flange is connected both at the top and the bottom, at these 2 points there is a sudden increase in the shear stress. There is sudden increase in the shear stress. So shear is critical at these points. So secondary inclined tension cracking near the spores, which separates the compression flange from the web. Typically, web shear failures are more sudden than the flexural shear failures. ठीक है जी? Web shear failures are more sudden. So you have seen this web shear cracks which originates at 45 degrees to the longitudinal axis, and flexural shear cracks which are less, you can say more flat or more horizontal, parallel to the longitudinal axis. These cracks are less abrupt, these cracks are more abrupt, ठीक है जी, and We have seen this that web distress, it can lead to the sudden formation of inclined cracks, which can lead to the failure in these possible three ways. One is the separation of the tension flange. Second is crushing of the web. Third is the you can say tension cracking in the what you say compression flange. ठीक है जी, which separates the compression flange from the web. So things are clear up to this point. Things are clear up to this point.
Yes, sir.
Okay. There is one or two students who have left the meeting. So they can rejoin the meeting. Okay. Now, next is the web reinforcement for the shear. Next point which we are going to study is the web reinforcement. Initial part of the lecture focused on different types of the cracking, and then focus was on the what you say shear stresses, flexural stresses. Then we studied about the flexural shear cracks and web shear cracks, and we said that the web shear cracks, they are more, you can say, they can cause more damage to the structural element as they are more sudden as compared to the flexural shear cracks. And flexural shear cracks and web shear cracks, in if you do what you're suggesting, you can observe that the flexural shear cracks, they are more flatter and you can say more horizontal to the parallel to the longitudinal axis, where the web shear cracks, they are more inclined at 45 degrees. As we know that the shear stresses, they are maximum at 45 degrees to the longitudinal. Okay, and based on what you say structural mechanics concepts which we have studied in undergraduate classes, based on those we can confirm that the shear stresses, they are maximum or inclined at 45 degrees to the horizontal. Now comes the web reinforcement, because the question here was that if web reinforcement is not provided, then we can have a shear compression failure. But of course, minimum amount of the web reinforcement for shear is always provided in the design. So we will now focus on this web reinforcement provided to cater the shear. So let's start. This is now more important part, as we are now proceeding towards what you say the design. So web reinforcement for the shear. Web reinforcement. Web reinforcement, it would be neither economical nor it will be safe to design pre-stressed concrete beams of such proportion that all the shear resistance is only provided by the concrete alone. ठीक है जी? So we know that the shear resistance is provided by the concrete and the steel. So if we do not provide the steel, then the shear resistance will only be provided by the concrete alone, and that resistance provided by the concrete alone may not be sufficient, to cater the applied shear. So it would be neither economical nor safe to design pre-stressed concrete beams of such proportions that all the shear resistance is provided by the concrete alone. Non-pre-stressed web reinforcement is employed of the same general form as used for the reinforced concrete beams. ठीक है जी? So non-prestressed web reinforcement कौन सी है? The steel reinforcement which we provided. ठीक है? So non-prestressed is the steel reinforcement. So non-prestressed web reinforcement is employed of the same general form as used for the reinforced concrete beams. Such web steel not only increases the shear strength of the beam, but it also ensures that in case of the overloading, produces a shear related failure, which is more ductile and less brittle. Just a moment, please. Yes, remember. ठीक है जी. So steel reinforcement is provided as in steel reinforcement is provided in the pre-stressed concrete beams as it is provided in the reinforced concrete beams, so that the such web steel not only increases the shear strength of the beams, but it ensures that in case of the severe overloading, it produces a more ductile shear behavior, shear failure. Yielding of the web reinforcement accompanied by the extensive concrete cracking would give some warning of distress. So remember this, that we always prefer that failure which gives us some sort of warning. So ductile failures are preferred. A brittle failure which occurs very suddenly is not what to say is a desirable failure. So I repeat, it would be neither economical nor safe to design pre-stressed concrete beams of such proportion that all the shear resistance is provided by the concrete, meaning there is no shear resistance from the steel as steel is not provided. However, this is not what you say desirable situation, and it is generally not followed as well. Generally, we do provide steel reinforcement uh, of the same general form as used for the reinforced concrete. Such web steel not only increases the shear strength of the beam, but it also ensures that in case of significant overloading, it produces a shear failure which is more ductile than otherwise. Like, we will prefer to have a flexure shear failure over the web shear failure because web shear failure is more brittle, whereas the flexure shear failure is relatively less brittle. So yielding of the web reinforcement accompanied by extensive concrete cracking would give some warning of the distress. At least a minimum amount of the web reinforcement is required in almost all of the pre-stressed beams. So now we confirm that a minimum amount of pre-stress, a minimum amount of web reinforcement is provided in almost all of the pre-stressed beams. ठीक है जी, minimum amount is provided. So advantage of this will be by providing the minimum web reinforcement that the failure will be more ductile. ठीक है जी. So yielding of the web reinforcement accompanied by extensive concrete cracking. Infrequently, vertical or diagonal pre-stressing is used in the web. Now you know that what you say webs are vertical part of your beam, vertical part. ठीक है जी. So it's relatively difficult. It is difficult to provide vertical pre-stressing or diagonal pre-stressing in the webs. ठीक है जी. So infrequently vertical or diagonal pre-stressing is used in the webs of the field. Although this offers the advantage that the principal tensile stresses and what you say diagonal cracking in the concrete can may be eliminated completely at service loads, but such methods in which you need to provide methods to provide vertical or diagonal pre-stressing, they are uneconomical. ठीक है जी. And secondly, practically they are not very much viable options to what you say to provide vertical or diagonal pre-stressing. In general, the pre-stressing which we have, that is longitudinal, ठीक है जी, along the length of the beam. So along the length of the beam. Let me show you one figure that can help you. Uh, this is a beam, a part of the beam has been shown, ठीक है. Sorry. This is what you say, this vertical part is your web part, and this is the, you can say, the web reinforcement being provided, this one, shear. And this is the pre-stressing tendon, a line which is passing or crossing the shear reinforcement, ठीक है जी, a line is passing. So we are saying that it is generally what you say, generally pre-stressing is horizontal, but if you have to provide vertical or diagonal pre-stressing, that is more difficult, ठीक है जी, and impractical, and it will be uneconomical as well. So infrequently vertical or diagonal pre-stressing is used in the webs of the beams. Although this offers the advantage that the principal tensile stresses and diagonal cracking in the concrete may be completely eliminated at the service loads, but such methods are uneconomical, and in addition they are not viable, impractical, ठीक है जी. So there is great practical difficulty in controlling the amount of the tension steel because of the large slip losses at the anchorages of the short tendons. So if you recall, we have studied that there are different types of the losses in the pre-stressing. In the immediate losses, we have the frictional losses, we have the anchorage losses, ठीक है जी. Whereas what you say, in case of the long term or time dependent, we have what you say, losses due to the creep, shrinkage, and relaxation of the steel. So in the short term, we do have the frictional and anchorage losses. So if we provide vertical or diagonal pre-stressing instead of the horizontal pre-stressing, that what will happen that there will be what you say, more anchorage losses. So vertical and diagonal pre-stressing is not preferable. Number one reason, it is uneconomical, it is difficult to implement in the field. Thirdly, the what you say, the losses, immediate losses, particularly the large slip losses at the anchorage, and you can say anchorage and friction losses at the start will be large. So practically it is not possible to provide vertical or diagonal pre-stressing. However, we will provide what you say, in the webs we will provide uh, non-pre-stressed reinforcement like this. So this is your web part of the I-shaped section, so T-shaped section. So you can see you have this U-shape what you say, web reinforcement. So minimum web reinforcement is always provided even in the pre-stressed beams. Everyone agrees to this point, this slide. So this slide basically we said that the shear resistance will be provided by, will be the sum of the resistance provided by the concrete and steel, ठीक है. Shear reinforcement will help us to have more ductile type of shear failure, ठीक है. Minimum amount of web reinforcement is always provided. Vertical or diagonal pre-stressing is not provided because it is expensive, it is impractical, and also there are larger what you say, slip losses at the anchorage. So immediate losses in case of vertical pre-stressing will be significantly large. And typical forms of the non-pre-stressed web reinforcement, the steel reinforcement that we provide as shear reinforcement in the pre-stressed beams are for beams of ordinary dimensions, deformed reinforcing bars of the sizes from number 3 to number 5 are common. ठीक है जी. Number 3 क्या है size? What's the number 3 size? जी, anyone? Number 3 size. Number 3 is your yes. Yes, it is 9.5 to 10 millimeter. And your number 5 is about 16 millimeter. ठीक है जी. So the common non-pre-stressed web reinforcements are typical forms of non-pre-stressed web reinforcements are shown below, which are commonly your number 3 to number 5. ठीक है जी. And the grades of the steel we commonly use are grade 40 and grade 60. So in uh, pre-stressed beams, we are using non-pre-stressed web reinforcement, which comprises of bar sizes which ranges from 9.5 to 16 millimeter. ठीक है जी. So and the grade of the steel which is being used, so the grade of the steel which is being used is 40 to 60. ठीक है जी. 40,000 psi or having yield stress 60,000 psi. So steels of higher strength used at corresponding higher stresses at service loads are apt to permit excessive wide cracks. So the point is, if you have larger steel reinforcement, of course it can allow you to go, it will take larger stresses. When the stresses will become higher, so what will happen? The cracking will increase. ठीक है जी. Because if you have smaller strength, lower strength steel, so then smaller stresses can only be allowed, and there will be what you say smaller cracks. So this is the disadvantage, you can say, in a sense, that when we are going with high strength steel, it can take larger stresses. So corresponding to larger stresses at service loads, there will be larger cracking, which is visually objectionable. ठीक है जी. So which is visually objectionable. So what we prefer, that we have smaller stresses and correspondingly smaller deflection, smaller cracking at the failure. So for beams of ordinary dimensions, deformed reinforcing bars of sizes from number 3 to number 5 are common, and steel of grades 40 or 60 are used. Steels of higher strength, on the other hand, used at the corresponding higher stresses at the service loads, are apt to permit excessively wide cracks. So stirrup bars are necessarily rather short. In most cases, it is not possible to develop the full yield strength of the bars by bond alone within the available development length. ठीक है जी. So for this reason, you need to provide special anchorages in the form of the hooks or the bends at the ends. ठीक है जी. Hooks or the bends at the ends. You can have 90 degrees hook, you can have 135 degrees hook. ठीक है जी. So stirrup bars are usually short. In most cases, it will not develop the wood full yield strength. Do you know what's the yield strength of the what's the full yield strength of the bars in the shear? That is, if you recall, that is 60% of the tensile yield strength. So shear yield strength is 60% of the tensile yield strength. If you recall in your undergraduate classes, when you were calculating the shear capacity, you were using one what you say value that was zero point 0.6 times Fy. That was to convert tensile yield strength to the shear yield strength, which is 60% of the tensile yield strength. Stirrup bars are necessarily rather short. In most cases, it is not possible to develop the full yield strength of the bars by bond alone within the available length of the embedment. Embedment length is generally not very large, so that's why full yield strength is not possible. So for this reason, we provide special anchorages in the form of the hooks or bends. So these are the types of the web reinforcement. In our case, we will be having I sections, or you can say T sections, pre-stressed beams. So in those cases, we have this type of the web reinforcement. ठीक है जी. In case of the rectangular cross sections, we can have the hooks or the bends. So is this point clear? Web reinforcement. So what we have said, that we will provide the minimum value of the web reinforcement, ठीक है जी, in pre-stressed concrete beams, and that web reinforcement will be non-pre-stressed. ठीक है जी, the ordinary steel which we uses in reinforced concrete beam. The size of the non-pre-stressed reinforcement will be from number 3 to number 5, and the grade of the steel will be 40,000 psi to the 60,000, grade 40 to grade 60, both are possible. And if we use higher strength steel, then it will result in larger cracking, which is not what you say visually does not look nice if you have very large cracks in the beam. So we will prefer to have ordinary strength steel, which produces lower stresses and correspondingly lower cracks at the service loads. ठीक है जी. So in general, embedment length is insufficient to develop the full yield strength. So to cater this, we provide increases in the form of the hooks or bends. Everyone agrees to this point, please? Please update me. Guys, can you hear me?
Yes, sir.
Okay, fine. Now, next is the reinforcing bars. This is the web reinforcement. We are continuing with this. The reinforcing bar bent in the form of the U. ठीक है जी, you can see this. These were the U's. ठीक है, web reinforcement. This is also basically U, and then you have the bent at the top. So U and bent at the top. So the reinforcing bar bent in the form of U, offering positive resistance to the pull out. Pull out क्या होता है? Pull out is that the bar is pulled out of the concrete because of the applied tensile stresses. So at the top, inward or outward facing bends or hooks are used. The reinforcing bar bent in the form of U, offering positive resistance to the pull out. At the top, inward or outward facing bends or hooks are used. At the top, you have inward or outward. So you can see we are providing hooks or bends in the form of, you can say, you have generally 90 degree or 130 degrees hooks. ठीक है जी. So that will help us to prevent the pull out. ठीक है जी. So the reinforcing bar bent in the form of U offers positive resistance to the pull out at the top. Inward or outward facing bends or hooks are used. In most cases, smaller dia longitudinal bars are added to the pre-stressed beams at the corners of the web reinforcement. These straight bars interlock with the stirrups, ठीक है जी, to improve the resistance of the pull out. So what we are saying that we can provide the longitudinal bars. ठीक है जी, longitudinal bars like this, longitudinal bars. So what will happen? They will, you can say, crisscross. And in most cases, these longitudinal bars are added to the corners of the web reinforcement. These bars will interlock into the stirrup, ठीक है जी, and improve the resistance of the improve the resistance against the pull out. ठीक है. So next thing which we are now going to study is related to the design of the shear. So we can have what you say a 5 minutes break here, and then we will restart our lecture, that is a shear transfer in partially cracked beam sections with the web reinforcement. So I will restart the lecture in a few minutes.
Okay, sir.